Welcome inside the laboratory at Protein BioSolutions. This is the ProteinMaker, designed for parallel purification of 24 proteins simultaneously. This instrument is brand new, still undergoing the final stages of quality assurance before being shipped. Before we do a demo run, let's start with a general introduction to the system components. Fundamentally, the ProteinMaker is a very simple system. It is made up of 24 pumps, each connected to a 9-port valve. 12 pumps are here on the front of the machine, and there are another 12 pumps in back. Having 24 individual pumps enables all 24 samples to be purified simultaneously. In addition to the 24 pumps, there is a robotic arm that moves in X, Y, and Z axes, navigating around the fraction collection deck. The fraction collection deck contains 19 positions for collection plates of various types and sizes, as seen here. There is an additional deck position dedicated for waste. As an option, you can get a chilled fraction collection deck to keep your samples at 4 degrees or any other desired temperature. Placing the entire ProteinMaker inside a cold room is also an option. Running 24 purifications requires buffer bottles of various types and other containers. We have various shelving options, such as this side shelf that can hold bottles of different sizes. Tubings coming in from the 9-port valves can be organized by grouping them together or by securing them in plates like this one. This shelf is also set up to hold and organize 24 250 milliliter bottles in case you want to perform a buffer scouting style experiment, purifying each sample with a different elution buffer. Columns can be attached to the system in different places, including on this optional front shelf. Columns are often attached nearer to the fraction collection deck on the robotic arm, but columns can be secured anywhere the user desires. Here's an example of a 110 milliliter size exclusion column that we used with the ProteinMaker secured beside the instrument. Our goal is to enable you to use the columns you desire. As mentioned before, each of the 24 pumps has its own 9-port valve. This enables many different solutions to be connected to each pump and accessible at all times. In this schematic, you can see one way that the system might be set up, although you might desire it to be set up differently. In this setup, we have a number of different buffers connected. We have a waste position, we have a step mixer that enables the automated mixing of multiple buffers on the fly, and we have one line enabled to aspire samples from the fraction collection deck. Again, every tubing represented in this schematic is replicated on each of the 24 pumps, providing maximum flexibility for you to perform the experiment you desire to do. Now, the ProteinMaker is not just a liquid handler. It is a dedicated purification system, equipped with UV monitoring as an optional upgrade. The UV system is seen here attached to the robotic arm. The gold circles that you're seeing are the UV detectors. Just behind the detectors are the flow cells, and just behind the flow cells are the UV light sources. There are 24 independent light sources and detectors, enabling live monitoring of all 24 lines. The UV system is field upgradable, so it can be added to the system subsequent to the initial installation. The ProteinMaker runs on dedicated software, designed to capitalize on the simplicity of the system while maintaining its inherent flexibility. This is the ProteinMaker software, used to control the instrument. We aren't going to go through all of the details of the software, but I will show you a few simple components and then run a demo method so that you can see how the software works. I do want to show you the column channel groups. This is what we use to group certain of the 24 channels together. For example, this group contains channels 1, 2, 3, and 4. We can add other channels to this group like 21, 22, or 23. We can take them away, name them as desired, etc. But this is the way that we enable communication to discrete groups of channels. This allows lots of flexibility. We can label the port positions. For example, here we see protein sample is labeled as the port 4. So that when you're building a method, the actual name of the fluid rather than the port number is displayed for you to see. So we are going to open this method. It's a simple method in which we will wash the column, load the protein, and then elute as a demonstration of how the control software works. So we will expand the method so that we can see all of the steps and details of the method and click Run to start the method. When you click Run, the method wizard comes up. It's really helpful to look at the Deck Configuration tab, which shows you what will happen at each plate position and reminds you which positions will be used. In this case, we are using the waste position, where the robotic arm just moved, and we are using the front 3 positions, which are holding these 3 24-well plates, 2 shorter and 1 taller. The software operates by grouping channels together, as we've already discussed, and then giving a command to that group. So the first thing that's happening in the video of the fraction collection deck is the washing of the column with buffer. You see the fluid dripping out into the waste position. What we've done in the method is programmed the group of columns 1, 2, 3, and 4 to pull from port 3, where there is wash buffer, and then push to port 9, which is the port that the columns are connected to. The robotic arm is positioned at the waste position so that the wash fluid coming through the columns goes to waste. Here we have the deck view of the software. The 24 red dots that you see represent the 24 needle positions, of which we just have the 4 connected in this video. You can see that it animates the red dots to show you the movement of the robotic arm, and here we have the picture-in-picture to show that movement to the left front position, which is holding a plate for collecting the flow-through. Here we are loading 1 milliliter of protein, collecting the flow-through in that plate. Back into the method view, you see the load protein sample submethod step. The gantry has moved to this position D1, the front left position. We have asked it to load from the protein sample port, port 4 as we saw in the column channel group. It will dispense to the column for a volume of 1 milliliter. Here in the deck view, you see that some of the wells in the crosshatched area are turning a light shade of blue. What's happening is that the deck view is logging the UV absorbance information. Collective absorbance information is logged for each well position. The more absorbance that is logged, the darker blue the well will become. This deck view is constantly updating so that it produces a relative picture of where the most absorbance has been logged over the whole fraction collection deck. This gives you a quick picture of in which plate or fraction the protein has come out. Now that we've loaded the sample and it is sitting out the column, we will elute it directly out for the sake of this demonstration. The robotic arm will move to the next plate position, D2, and elute the protein off of the column and into the plate. If we click over to the UV tab, we can see that we are starting to get an indication that the protein is coming off of the columns and coming through the UV monitors. We have different modes that the UV tab operates in. I've clicked over to the real-time mode, which refreshes every second or so. You can see simple peaks coming out as I move the view to see a bigger picture overview. You can also look at the plots in different ways, but here's again an overview of where things stand. Now, as we come back to the deck view, you can see that these first 4 wells in the second plate are quite dark blue, indicating that far more absorbance was logged in these wells than in the 4 wells of the first plate, which is what we would expect, of course. This confirms that our protein did come out in these elution fractions. The robotic arm has now moved over to position D3, where we will wash the column since the elution has now been completed. Eventually, we will likely see the 4 wells in this third plate turn a light shade of blue as small amounts of absorbance are logged during the column wash. Here we are in the final step, washing with 5 milliliters of water. If we go back to the UV tab, we can see the traces for the 4 channels. We can change the view on the UV tab to look at the trace in terms of time or volume. The method being nearly complete, if we had walked away and were just coming back to the system, we could see in the deck tab that indeed our protein did come out in the second plate. In the method, the green check marks along the right side track progress and show which steps have been completed. Looking at the UV tab again, we can cycle through different views. With the method now complete, it provides this confirmation. Before we close out the video, it might be useful to see the information that is logged. There are several different logs. We have the deck log that we can interact with, and the UV log is also available to interact with zoom in and out. The method log shows the method we ran. It is no longer editable, but we can double check to see what was done. Lastly, there is a log that contains the commands run throughout the method. Here at the bottom it shows how much volume was pumped from each of the port positions. From this you can determine how much buffer volume should be prepared before starting the run. All you have to do is run the method in simulation first so that it will display this information for you. Thanks so much for watching this demo video. We hope that it will help you understand the utility and flexibility of the ProteinMaker. If you have any questions or would like to learn more, please contact us at info@pbiosolutions.com.